Welcome back, everybody. Excited to dive into a book today that really flips the script on how we think about our bodies.
Oh yeah, the Bioelectric.
By Robert O. Becker. It's one that makes you reconsider the role of electricity in, well, pretty much everything our bodies do.
Definitely goes way beyond just like the basic nerve impulses.
Yeah, and we got excerpts to work with today, so we'll be jumping right into Becker's own words.
Looking forward to that. I think listeners will be really intrigued by some of his findings around healing and
Regeneration. Yeah, that's the big one, right?
it's like something out of science fiction. But Becker makes it pretty compelling case.
Well, let's start there then. How did he even begin to connect electricity with something as complex as regeneration?
Well, he starts with a question that I think a lot of us have pondered. How is it that certain creatures like salamanders can regrow entire limbs? It's a pretty amazing feat.
It is. It's like a superpower. But how did he bridge back to the electrical side of things?
A lot of this stems from the work of Dr. Harold S. Burr. He proposed this concept of fields of life, basically suggesting that all living things are shaped and controlled by these invisible electrical fields.
So like an electrical blueprint guiding our development.
Exactly. And Burr's research indicated that these fields weren't static. They actually changed as an organism grew and developed.
So they're dynamic, not just a fixed pattern.
Right. And get this, Burr's work even hinted that these fields could reflect the health of an organism.
Okay, now that's getting interesting. So Becker took that idea and ran with it.
He did. He theorized that electricity wasn't just about nerve impulses. It was a much more fundamental system woven into all sorts of processes we hadn't even considered before.
So beyond the obvious sparks of our nerves, there's this whole other level of electrical activity happening.
Exactly, like a hidden language the body uses to communicate with itself.
What did Becker find out about this deeper system? What was he seeing?
One of his big discoveries was the presence of these direct currents flowing throughout the body, completely separate from the nervous system.
Direct currents, like what we use to power our electronics.
That essentially. And he observed them in a variety of processes, but particularly in bone fractures, which is fascinating when you think about it.
Our bones are part of this electrical network. I always thought they were just, well, hard structures.
Right, that's what makes it so intriguing. When a bone breaks, there's a surge of electrical activity at the fracture site. Becker called it the current of injury.
Current of injury, that's a pretty evocative name.
It is. And he believed this current acted like a signal, drawing healing cells to the area and guiding the repair process.
So like a built-in electrical repair crew, FPRIOS.
Oh yeah, and what's even more fascinating is the connection Becker observed between this current of injury and the regenerative abilities of certain animals.
Hold on a minute, you're saying the better an animal isn't regenerating, the stronger this current is?
That's what his research suggested.
Okay, so does that mean humans could potentially regenerate too? I mean, if we could just boost that current.
Becker was definitely interested in that possibility. He even conducted experiments on rats, implanting electrodes to try and stimulate limb regeneration using these currents.
Did it work? Did he create a bunch of tiny wolverines running around the lab?
Not quite.
Bad.
He observed some accelerated healing and some bone and tissue regrowth, but full limb regeneration remained elusive.
Okay, so no superheroes yet. But even without full-blown regeneration, this idea of a current of injury is pretty mind-blowing.
It really changes how we think about healing. It makes you wonder about all the other ways these electrical currents might be influencing our bodies.
Well, got the perfect place to pick up next time. We've only just begun to scratch the surface of the body electric.
There's so much more to uncover.
Yeah.
Becker had some really interesting ideas about the brain's role in all of this.
We'll be sure to get into that and much more when we return for part 2 of our deep dive into the body electric.
See you then. So we're talking about this idea of an electrical network in the body.
Yeah, beyond just like the nervous system.
Right, Becker wasn't just talking about isolated currents. He was suggesting an entire electrical communication system, something just as intricate as the nervous system maybe.
Wow, so this network could be carrying information all throughout the body.
Potentially even influencing our consciousness.
Consciousness, now that's a big leap. Did Becker actually have any evidence to back that up? I mean, the connection between electricity and consciousness?
Well, he was always careful not to overstate his claims. But he did point to research on near-death experiences and things like altered states of consciousness that are induced by stimulating the brain with electricity.
So those experiences suggest a deeper link between our minds and electricity.
That was his thinking. He felt like those experiences hinted at something we don't fully understand yet.
It's definitely mind-blowing to consider. I mean, if our consciousness is electrical in nature, what happens to it when we die?
That's the big question, isn't it? one that's puzzled philosophers and scientists forever. Becker definitely acknowledged that we're nowhere near having a definitive answer.
Okay, some mysteries are best left unsolved for now. But let's get back to this skeletal network. Did Becker ever try to map it out? But what did he think it actually looked like?
He did identify some key structures that he thought played a role. What those interesting ones is the perineural system. It's a network of connective tissue that surrounds the nerves.
Connective tissue? Isn't that just like the stuff that holds everything together? Why would that be involved in electrical communication?
That's what's so cool about it. Connective tissue is often overlooked. But Becker found evidence that it could actually conduct electrical currents.
So it's not just packing material, it's part of the circuitry.
Exactly. And this perineural system could be a key part of how electrical signals travel throughout the body.
Okay, but if this perineural system is so important, how does it actually work? What's the mechanism?
Becker proposed that it might act like a slower communication system, using direct currents to transmit information over longer distances and over longer periods of time than the nervous system.
So we have the fast nerve impulses for things that need to happen quickly, and then this slower, more gradual system running in parallel.
Right, like two different modes of communication, each with its own purpose.
So what would this slower system be used for?
Think about things like growth and development or long-term healing. These are instantaneous processes. They unfold over time. So maybe they require a different type of signaling.
It's like the body's long-distance network, keeping everything in sync over the long haul.
That's a great way to put it. And remember how we talk about the brain being the conductor of this electrical orchestra?
Yeah, so how does the perineural system fit into that?
Becker believed that the perineural system could be the link between the brain's electrical activity and the rest of the body's electrical network.
So it connects the conductor to the instrument?
Exactly.
This is all pretty complex, but what's the practical takeaway for the average person? Why should we even care about these subtle electrical currents?
Because Becker believed that understanding these forces could completely revolutionize how we approach healing. Imagine if we could actually tap into these currents to accelerate the repair of injuries, maybe even regenerate damaged tissues.
Okay, now that would be incredible. But even without the really futuristic stuff, just understanding these currents could change how we treat injuries and illnesses that we deal with every day, right?
Absolutely. And Becker's work suggests that these currents are involved in so much more than just literary repair. They could be affecting growth and development, immune function, even our response to stress.
So this internal electrical system is like a master control panel, impacting our health and well-being in countless ways.
It's a pretty powerful concept, and it makes you look at things like acupuncture and electrical stimulation therapies in a whole new light.
Yeah, those have been around for centuries. But Mimi Becker's work gives us a framework for understanding why they might actually work.
It's like we're starting to bridge the gap between ancient wisdom and modern science.
So if Becker was right about all this, why isn't bioelectricity more mainstream in medicine?
Well, his ideas were pretty radical, especially at the time. He was challenging a lot of the assumptions about how the body works.
He was a bit of a scientific maverick.
You could say that. And not everyone in the scientific establishment was on board with his idea.
So some people were skeptical.
Yeah, there was a lot of pushback. And it's not that there was necessarily evidence against his ideas. It was more that more research was needed to really understand and validate them.
So it's not that he was wrong. It's just that we need more time and more research to really figure it all out.
That's the nature of science. It's a process of constant exploration and discovery.
And Becker definitely pushed the boundaries of that exploration. He opened up all sorts of new avenues for research.
And his work continues to inspire scientists today.
Yeah.
Even though he faced skepticism, he never stopped asking questions and seeking answers.
And those questions could lead to some amazing breakthroughs in the years to come. I mean, if the body electric has taught us anything, if that we might be capable of far more than we realize.
It's about opening our minds to new possibilities. And that's what makes science so exciting.
It really makes you wonder just how much we still don't know about our own body.
Oh, absolutely. We're only just beginning to scratch the surface, especially when it comes to things like bioelectricity.
And Becker wasn't just an academic theorizing about this stuff. He was a surgeon, too.
Right, which is a really important point. His surgical background had a huge impact on his research.
So did being a surgeon give him a different perspective on his electrical system?
Definitely. As a surgeon, he saw firsthand how incredible the body's ability to heal is. Bones mending wounds, closing tissues regenerating. But he also saw the limitations of conventional medicine.
I imagine he encountered cases where healing just didn't go as planned.
All the time. And sometimes healing was just painfully slow. Those experiences really fueled his desire to find new ways to enhance the body's natural healing powers.
And he saw bioelectricity as a key to unlocking that potential.
Exactly. He thought it could help us overcome those limitations, push the boundaries of what was possible in medicine.
It sounds like she was driven by a deep compassion for his patient.
Oh, absolutely. He was a visionary, but he was also very practical. He wanted his research to lead to real-world applications that could actually help people.
Did he have any specific ideas about how bioelectricity could be used in medicine?
Oh, he explored all sorts of possibilities, using electrical stimulation to speed up bone healing, treat chronic pain, even regenerate damaged nerves.
Those are some pretty ambitious goals. Did he see any success?
He did, especially with bone healing. Some of his work actually led to the development of electrical stimulation devices that are still used today to help treat bone fractures that are slow to heal.
Wow, so his research is already having a real impact. It's amazing to think about. Makes you wonder what other breakthroughs are waiting to be discovered.
Right. I mean, the possibilities are vast. And it's not just about directly stimulating healing with electricity. Becker thought that understanding these electrical systems better could also lead to new drugs and therapies.
So instead of applying electricity directly, we could develop medications that work with the body's own electrical systems.
Precisely. It's a fascinating area of research. And some scientists believe it could lead to some really revolutionary treatments for things like cancer, heart disease, neurological disorders.
It sounds like we're on the verge of a whole new era of medicine.
It's definitely an exciting time to be following this field.
But before we get too carried away, we have to remember those ethical considerations we talked about earlier. Any powerful technology have the potential from this use.
Absolutely. Especially when we're talking about manipulating the body's electrical systems, especially the brain. We need to be incredibly careful. Proceed with a strong sense of ethical responsibility.
It's a delicate balance. Finding ways to advance scientific progress while also making sure these technologies are used for good.
Exactly. And it's something we need to be adding open and honest conversations about right now, before these technologies become even more powerful and more widespread.
Well, it seems like Becker's legacy isn't just about his groundbreaking research. It's also about the profound questions he raised about the nature of a life consciousness and the responsibility that come with scientific advancement.
He really challenged us to think differently, to consider possibilities that seemed impossible, and to approach these discoveries with a sense of wonder, but also with the deep respect for the complexity of the human body.
Well, this deep dive into the body electric has definitely given us a lot to think about. It's a journey into the intersection of science, philosophy, and ethics.
And it's a reminder that we still have so much to learn about the human body. It's a frontier full of mysteries waiting to be explored.
And who knows, maybe those mysteries hold the key to unlocking our full potential. Thanks for joining us on this electrifying exploration of the body electric. We'll see you next time for another deep dive.